Hi, in the previous video, we've set up the complete model of the Phillips curve relationship, so the interaction between inflation and unemployment. We've explained all the parameters, all the equations. Now we need to find the solution to the model. So what we need to do here is to first condense this model, these three equations into one, and we need to express it as a second order differential equation with just one variable alone. The variable that we are choosing is expected inflation. Okay, so let's start. Let's start with equation number 2, where we have d pi dt equal to j times p minus pi. And now look, right away, we can substitute for p over here and substitute the first equation. Now that we have two equations in our setup. So we've got that this is j times alpha minus t minus beta u plus g pi minus j pi. Okay, now we can also simplify this quite easily, and we get that this is j times alpha minus t minus beta u. That's it. And out of these two, we can get that this is equal to so we will have minus j1 minus g pi. Okay, right. So now we've put two equations over here. The next step that we're going to undertake is to differentiate this equation to get second derivative. So look, I'm differentiating everything you see over here with respect to time. But look, in our model, endogenous variables are only p, pi, and u. So in this case, I just need to differentiate those two expressions. So for example, this is gone in differentiation. So I've got that this is negative j beta du dt minus j1 minus g d pi dt. Okay, and look, I hope that at this moment you can see what should be our next step. Well, we haven't used the last equation, right? So now let's substitute for du dt over here. Okay, so this is gonna be minus. Okay, no, first minus and minus will give us plus. So this is going to be j k beta m and minus j k beta p, and we've got here minus j1 minus g d pi dt. Yeah, I don't think I made any mistakes here. And look, now we've already condensed the knowledge coming from these three equations into just one equation over here. However, again, we've got P over here, so we've got inflation. And what we are missing for this to become the full second order differential equation right? However, there is a simple trick to get this one. Let's go back to our equation over here for expectations formation. So we've got j times p minus pi, right? We can get out of it, okay, right away, that this is jp minus j pi. And look, if I'm going to move this to the other hand side of the equation, I'm going to get that this is j, that jp is equal to d pi dt plus j pi, right? And just move j pi to the other hand side. Dividing both sides by j, we get that p is equal to 1 over j d pi dt plus pi. And look, what we can do now is to substitute this p, so inflation, over here. Okay, so we got from here that d squared pi dt is equal to, well, this stays the same. We've got just j k beta m, and now minus. Look, let's substitute one by one. If I'm substituting this part first, so first part of p, j's will cancel each other out, right? So we've got minus k beta d pi dt, and if I substitute pi, I just get negative j k beta pi, and the only thing left is negative j1 minus g d pi dt. Okay, and look, now we've got everything we wanted. Just now let's organize this equation in such a way that we are familiar with it, right? So definitely we're going to start with d squared pi dt square, of course. And then first we need to move this and this to the other hand side of the equation, right? We need to combine those two and move them to the other side. So we're going to have plus k beta plus j1 minus g d pi dt, then plus j k beta pi, and this is equal to j k beta n. And look, this is our second order differential equation. This is our y's. This is our a1, y prime. This is our a2. This is our y, and this is our b. Okay, so I hope you now see that solving it's not going to be that problematic. First thing we do, if we want to solve it, is to find particular integral. So our equilibrium solution, right? This is b over a2, right? So we got that this is j k beta m and j over jk beta, which is equal to m. And from that, we get that in equilibrium, expected rate of inflation is equal to the growth rate of money supply. So this is exactly the result you got in your macroeconomics class when you were talking about what happens in the long run, after economic agents adjust their expectations. Okay, so now that we have particular integral, the only thing left is, of course, to find the complementary function. And look, the form of the complementary function is not interesting to us, actually. We need to just make sure that the model is dynamically stable. So actually, that model goes back to this value. So expected price level, expected inflation is equal to expected nominal money growth. Okay, so look, what do we have here? A1 is equal to K beta plus J 1 minus G, and this is a positive outcome, right? Positive, 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 between 0 and 1, between 0 and 1, so also positive. We know that this is bigger than 0. Also, A2 is J, K, beta. So 4A2 is 4J, K, beta, and it's also positive. So look, in this case, here we see that we can actually have all three cases. Case number 1, we can have case number 1 when we have real distinct roots. Okay, that would be the case where A1 squared is bigger than, 4A2. So in this case, we get that K beta plus J 1 minus G squared is bigger than 4J K beta. Okay, in this situation, the roots, characteristic roots, which are given by 1 over 2, negative A1 plus minus square root of A1 squared minus 4A2 are equal to 1 over 2 times minus K beta plus J1 minus 1 minus G. Right? Plus minus K beta plus J 1 minus G square minus 4J K beta. Okay, now the question is, are those two roots that we've got over here positive or negative? Or maybe one is positive. But let's notice one thing. Look, this expression is negative, which is the good sign. At least one of the roots are going to be negative. But look over here. This number over here is definitely lower in absolute value. Is definitely lower than this. Why? Because look, here, to get this number, we would have to take square root out of this, right? But here we are subtracting positive number, which means that we will have a smaller number. And again, we are at the situation where, let's just say this is the number where we're starting from. This will be our second root. This will be our, let's just say, first root. Usually the other way around. We see that both roots are clearly negative. So we see that under case number 1, both roots are negative. Model is dynamically stable. Okay, how about case number 2? What if it happens to be that A1 squared is equal to 4A2? Well, then we will have repeated roots in the form of negative A1 over 2, which is equal to negative K beta plus J times 1 minus G divided by 2. This is clearly positive because minus up front. Again, we have positive, again we have negative outcome, we have dynamic stability. And finally, we can have case number 3, some complex roots. But look, in case of complex roots, H, again, is equal to negative K beta plus J 1 minus G over 2, which again shows us exactly the same outcome. Regardless of what the case happens to be, the equilibrium we've reached. So when expected inflation is equal to growth rate of nominal money supply is dynamically stable. So if something happens to in this model, of course we're going to be out of this equilibrium. Customers, agents will either expect higher or lower inflation for a period of time. But as enough time passes, expectations go back to the level dictated by nominal money growth. Okay, so this is it about the Phillips curve. In next week, we're gonna do some finishing touches on our knowledge on second order differential equations. And that's it for now. Thank you for your attention.